qualitative analysis of cations, a sample question. Hello and welcome to another of Dr. Sirme chemistry demonstration experiment. In my previous two uploads, I have been doing qualitative analysis of cations. In the first one, I did qualitative analysis of cations using aqueous ammonia. The second one, we did as qualitative analysis of cations using sodium hydroxide. And then I promised to bring you a sample question, and then you see how do I use the two solutions, or rather, how do you do the analysis of cations using what we call selective precipitation, because that is all that we were doing. And therefore, we have a known. I have a known solid here marked X, or rather it is labeled X. And the X, the appearance is just that it's a white solid. It's just a white solid. So the step number one, if you're given a known substance in solid state and you want to do the qualitative analysis, you have to first of all dissolve it in water. So the step number one would be you take a boiling tube, you place all the solid into a boiling tube, then add water, add some water, then just shake it. You ensure that the solid has dissolved. Yes, the solid has dissolved to form a colorless, or rather a clear solution. And that tells you, remember that will be the observation. The inferences will be that the solid X is a polar substance. Or rather, you can say there is absence of the colored ion because it has formed a very clear solution. Remember, at the beginning, I'm told that the solid X is suspected to have two cations. So I'm going to analyze and get the two cations. So what I'll do, I'll be directed clearly that I need about 2 cubic centimeters of the solution that I've prepared. So I'll need like 5 samples. I need 5 samples of the solution I have prepared. Use another sample, then the 5th one, I need about 5 samples of the solution that I've prepared. Remember now I'll be working with sodium hydroxide. This is sodium hydroxide. Hope you can see that. 2 molar sodium hydroxide. I'll be working with aqueous ammonia. This is ammonium hydroxide, or rather aqueous ammonia. I'm having sodium sulfate. This is sodium sulfate. I will also work with sodium chloride. I'll be having sodium chloride. Yes, sodium chloride. Then I'll also have Ki, the potassium iodide. Now, where do I start? We said sodium hydroxide is for the preliminary. It is the one that gives me the clue, the hint of what chemicals, what cations are present in the sample. So in the first one, I'll be required to add few drops of sodium hydroxide, then I add excess. So with few drops, remember in this case, you're not supposed to shake. With few drops, a white precipitate. Then I add excess of it. I will add excess of sodium hydroxide. Excess of sodium hydroxide. Yes, the excess of it. Remember, with excess, you need to add excess just to be sure. Just to be sure. And here you're allowed to shake. So the white precipitate is disappearing. The white precipitate is disappearing. So just to be sure, with excess of sodium hydroxide, add enough. So this one has formed white precipitate that has dissolved in excess sodium hydroxide. So judging from what we had done before, there are three possible cations that are present in there. Either it is zinc 2 ion or zinc ions, it can be lead 2 ions or aluminium ions, because those are the three hydroxide that we say they are amphoteric and they dissolve in excess of sodium hydroxide. So I go to the next one. I'll have a sample of the same. This is a sample of the same. Then I will be adding aqueous ammonia. I'll do just a drop or two, a few drops, and a white precipitate is formed. Then I'll add excess of it. I will do excess of sodium, or this is now aqueous ammonia. I will add excess just to be sure, just to be sure. And you can see what has happened. The white precipitate is very much insoluble. The white precipitate is insoluble. You can see that. The white precipitate is insoluble. And that now brings you to another conclusion, what we call the inferences. The inferences are just the deduction, the chemistry behind the observation. So if I have added aqueous ammonia and I have observed a white precipitate that was insoluble in excess of aqueous ammonia, and remember the step number one gave me the hint that in that analyte, the chemical we are trying to analyze, it had aluminium, zinc, or lead 2 ions. Out of the three, it's only the aluminium and lead 2 ion that will not dissolve in aqueous ammonia. So we rule out the zinc 2 ions. So we continue. We now want to confirm between lead 2 ions and aluminium ion, which one is present. We will be guided by solubility of salts. Now I need the third sample and I introduce a sulfate. I will introduce a sulfate in form of a sodium sulfate. I will add, in this case, I'm supposed to add just 3 drops, and or rather few drops. With few drops, a precipitate has been formed. So if a precipitate has been formed, it means it is not an aluminium ions, but lead 2 ions. Why? Because if it was aluminium sulfate is soluble, so it cannot form a white precipitate. But for this one, the white precipitate is because the particle present was lead 2 ions. And that's why it formed lead 2 sulfate, which is insoluble, the white precipitate. Maybe I still need another step to do a confirmation. And how do I do the confirmation? So I can take the third or the fourth, in this case, sample or a portion of what solution I divided, and I bring in the chloride. So I can add 2 drops of chloride. So if I add 2 drops, I get a white precipitate. And with a white precipitate, it confirms that lead 2 ions might be present. But just to be sure, I can warm. If I do the warming, it will tell me, is it truly a chloride ion or not? Because if it is a not chloride, but lead 2 ions. If it is lead 2 ions, the chlorides, the lead 2 chloride will dissolve. So I only need to warm. I do the warming. If the precipitate is going to dissolve, if the precipitate dissolves, then it is true that the solution that the cation that I was trying to analyze is lead 2 ions. If you observe keenly, I don't know if you can see, the precipitate dissolves. With a little warming, the precipitate just dissolves. The solution is very clear. So with this, the precipitation has dissolved, so it confirmed it was lead 2 ions. Otherwise, I can still use the Ki, the potassium iodide. If I have the solution that I was analyzing, then I add potassium iodide. Good. That helps me to confirm that truly the cation that I was analyzing is lead 2 ions, because lead 2 ions, when it combines with the iodide, it forms the yellow precipitate, that is the lead 2 iodide. So with that, I've carried out step-by-step analysis to show you the cation that was present in the unknown sample, that is the lead 2 ions. Okay, from the beginning, we are told that the cations we are having, the were 2. And to get to analyze the second cation, I need a glass rod. I dip it into the solution. Then I introduce, or I subject the drop from the solution to a non-luminous flame. Then I observe the flame. For this case, a golden yellow flame has been produced, and that indicates that the cation present was sodium. Basically, why do we go for flame test? These are cations that cannot be precipitated that easily with sodium hydroxide, and these include the cations very high in the reactivity series. For instance, potassium, if you subject it, it gives you a lilac or purple color or flame. If it is magnesium, it gives you the brilliant white. If it is lithium, it gives you the brick red. Be it the calcium, gives you the crimson red, etc. etc. Otherwise, thank you so much for watching.